Hey guys, welcome to lesson 3. This is solving radical equations, and we have solved equations through all of Algebra 2B. So this is nothing new, it's just a new thing that we're applying to solving equations. So we kind of talked about this back in lesson 1. So we're really going to get the radical by itself before we can do anything. And then just like we, so let's pretend like we had x squared. We got the x by itself by taking the square root, because this is the same thing as 2 over 2. Oops, sorry. And that simplifies to x to the first, or just x. So that's what we want. So now we're going the other way. So we have a root that we're taking to the second power, whatever. So let's look down here. So we've got this root by itself. So I'm going to undo the root by taking it. Remember, this is implied that it's a 2. So I'm going to take this to the second power. So just like before, whatever we do to one side, we have to do to the other side. So this cancels out to 1. So we have 5x plus 1 equals 36. And then from here, just basic algebra, subtract 1 and divide by 5. So x equals 7. Make sure that you always go and check your solution and make sure it's okay. So let's see. 7 times 5 is 35 plus 1 is 36. And the square root of 36 is 6. So that works just fine. Okay, so let's go here. Notice that the radical is not by itself for this one. So we are going to have to subtract 13 and then divide by 2 before we can really do anything. Sorry, it's a negative, isn't it? Before we can do anything. So I have the square root of 24x equals 12. And so square root, I'm going to take it and square it to undo that root. So I'm going to do the same thing over here. So I have 24x equals 144 and divide by 24. And 144 divided by 24 is 6. So let's see. I'm going to plug in 6 here. So 24 times 6 is 144. The square root of 144 is 12. 12 times negative 2 is negative 24. And negative 24 plus 13 is negative 11. So yeah, that works perfectly. So this one, notice that I have this 4 on the outside. So I'm going to subtract 4. Ooh, sorry. Just notice there's a typo there. So that square root stops right here. So I'm going to subtract 4 on both sides. So I have the square root of x minus 1 equals 5. Now I have the square root by itself, so I'm going to square both sides. I have x minus 1 equals 25. Add 1 to both sides is 26. So let's see, I'm going to come up here. So 26 minus 1 is 25. The square root of 25 is 5. 5 plus 4 is 9. So, you know what, guys? I just caught a mistake. So I'm thinking, okay, well, that's not right. But look, 5 minus 4, that is 1. So let's go ahead and fix that. So that's kind of nice checking it, too. You can catch some mistakes that way. So I have x minus 1 equals 1, because 1 squared is 1. And then plus 1, I have x equals 2. Now let's try this. So 2 minus 1 is 1. Square root of 1 is 1. 1 plus 4 is 5. So that works. Okay, notice this one. This is a different root. So this is the cubed root. So I'm going to undo it to the third power. So I'm going to take both sides to the third power. These cancel out. And I have 3x minus 4 equals 8. I'm going to add 4 to both sides, which is 12. And divide by 3. X equals 4. So let's check it again. So I have 12. Right? 3 times 4 is 12. Minus 4 is 8. The cubed root of 8 is 2. I like it. Okay. So let's do this down here. So again, notice the roots are kind of switching up on us. So we're going to divide by 6 because we have that stuff on the outside. So I have the 4th root of x plus 10 equals 7. And I'm going to take this to the 4th power. So I have x plus 10 equals 2,401. And subtract 10 from that, and I get 2,391. And again, we can check it and see if it works. So let's see, 2,391 plus 10 is 2,401. And then I'm going to take the 4th root of that. And I get 7, and 7 times 6 is 42. I like it. Okay, so now we're going to, for this one, subtract 12. Divide by -5. And I get the cubed root of 8x equals 4. So I'm going to take this to the 3rd power. 4 to the 3rd power is 64. So these cancel out. I get 8x equals 64. Notice, I was going to say this, like on these even roots, notice we're not doing, or even exponents, we're not doing roots, so we don't have to ever worry about plus or minus when we're going in this direction. If we were taking like the 4th root, then we'd have to, but since we're taking it to the 4th power, we're good to go. Okay, so I have x equals 8. 8 times 8 is 64. The cubed root of 64 is 4. 4 times -5 is -20. -20 plus 12 is -8. So it works as well. Okay, see if you can do these last two on your own. They're no, sorry, they're different. Okay, so we are going to square both sides. So I have 9x minus 18 equals x squared. So this is the first time, notice this one over here. When I square it, I'm also going to get an m squared. So we have to treat these a little bit differently. Think like factoring quadratics or solving for quadratics. So really the majority of the time we're going to just set everything equal to 0. So I'm going to move this over so that x squared can be positive. I like that. So this becomes a 0. So I have x squared minus 9x plus 18 equals 0. And then I'm just going to factor it. So let's see, x minus 6, x minus 3. So x equals 6, x equals 3. So be really careful because these are where the extraneous solutions come in. So we really need to make sure that we check these. So check 6 and 3 and see if they work in this problem. So I just checked them and they both work just fine. So let's go ahead and do this one over here. So I'm going to subtract 77 and add 4m to both sides. Just cleaning it up over here. So I have m squared plus 4m minus 77 equals 0. And then let's go ahead and factor that again. So let's see, 7, 11 plus minus. So we have m equals 7, m equals -11. So again, go ahead and check those and see if they make sense in make the equation true. Okay, so when we plug this one in, it's just fine. But when we plug this one in, that is not good. So my only true answer is 7. Okay, now we're going on to the second part. And so this is where we've talked about extraneous solutions. That's what we've been checking. So let's see what happens here. So when I square this, I get x plus 2 equals 9, and then subtract 2, I get x equals 7. So let's see if this works. So when I plug in 7 plus 2, that's 9. The square root of 9 is positive 3, and my answer is -3. So this is an extraneous solution. So that's the same thing that happened up here. It's extraneous. Okay, so these problems, we've been doing problems like this. This is nothing new, but these are kind of yuckier. So I know that I need to square both sides to get rid of the square root. So this side becomes nice. But this side, when I square it, I end up with x plus 1 times x plus 1. And this is 7x plus 15. So I'm going to have to multiply these together. And when you do that, you should get x squared plus 2x plus 1 equals 7x plus 15. So I'm going to move these over here, and minus 7x minus 15. I get x squared minus 5x minus 14 equals 0. And then I'm going to factor that. So x minus 7, x plus 2. So that x equals 7, x equals negative 2. I'm going to tell you, when you're checking for extraneous, a lot of times it's in the negatives. Not always, but sometimes. So go ahead and check those and see which one works and which one does not. Okay, so you should have seen that, again, the negative does not work. That is not always the case, but several times it is. Okay, so let's go on to this last one. So we're going to do the same thing. So we're going to square both sides. So I get x plus 3 squared is x plus 3 equals 10x plus 9. So I get x squared plus 6x plus 9 equals 10x plus 9. Well, the first thing I notice is it's got a 9 on both sides, so we can cancel that out. I'm going to subtract the 10x. So I get x squared minus 4x equals 0. So let's factor out an x. So x times x minus 4 equals 0. And I get x equals 0 from this guy, and x equals 4 from the married couple. So when you check those, they both work. So we have 2 solutions there. Okay, so now we're going, that's about as yucky as it's going to get in this class. So for this topic anyway. So we're going to switch gears and get away from the radical form, and we're going to go to exponential form. So just like the radical form, we are going to get rid of any junk that's on the outside. So that's junk, 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 you know, you get the idea. So we're isolating that exponent by itself, the base and the exponent by itself. So let's divide by negative 2. So I get x to the 3/4 power equals 8. Okay, so just how I talked about how I neutralize the square roots. So if I were to write this down, it would be 10x plus 9 to the 1/2 power. And then when I square it, that becomes 2/2, which is 1. So my goal is for this to become a 1 to kind of neutralize out that root. So same thing applies here. It just looks different. So whatever this is, I'm going to take the reciprocal of it, because 3/4 times 4/3 is, I can cancel that, that equals 1. So that neutralizes it if I take the reciprocal power. So whatever I do to one side, I'm going to do to the other side. And like I said, these cancel out, and I get x equals 8 to the 4/3 power. So see if you can figure out what that is. Okay, so the cubed root of 8 is 2. 2 to the 4th power is 16. Okay, so let's do another one. So let's divide by negative 2/3. So when you divide by a fraction, you multiply by its reciprocal. So I get positive 3. So x to the 1/5 power equals positive 3. So then don't forget, you're going to multiply by the reciprocal, which is 5/1, multiply that by reciprocal. So I have x equals 3 to the 5th power, which is 243. Okay, don't let this scare you. Just because it's in parentheses, that's okay. We're still going to treat it the same way. So 4/3, we're going to raise it to the 3/4 power. And these cancel, so I get x minus 5 equals, let's see, the 4th root of 81 is 3. 3 to the 3rd power, is 27. And let's go ahead and add 5 to both sides. So I get x equals 32. So again, don't forget to check these. I just checked 32 and it works perfectly. Okay, so let's go to this one. So we have minus 3 And so I'm going to raise it to the 3/2 power. So the square root of 4 is 2, and 2 to the 3rd power is 8. So these cancel out. So I have x plus 2 equals 8. And then I'm just going to subtract 2. So x equals 6. Okay, we have 2 more, and then we're going to deal with some word problems here. These are super nice. They are your friends. Look for them because we are just going to get rid of that square root. So we're going to square both sides. And what happens is these cancel out. So I have x plus 3 equals 4x minus 8. So it becomes a really nice problem. So x equals 11/3. Even though this is a cubed root, these look really scary also, but they're not. We're just going to take it and then do it to the 3rd power. So again, these cancel. I'm left with 4x minus 9 equals 2x minus 4. I'll subtract that 2x from both sides. 2x minus 9 equals -4. Add 9. I get 5. Divide by 2. X equals 5/2. Okay, so let's talk about these word problems. So this is very similar to the word problem in part 1, lesson 1. So really, the main thing that I want you to see is that this is your equation. So I'm digging through, trying to figure out, okay, well, what is S, what is R? So go ahead and see if you can find that. Okay, well, it tells us that S, it gives us the surface area of the sphere, and it actually gives us that, which is 7,854. So I know that's S, and then 4 pi r squared. So I'm assuming I'm figuring out R, and so let's kind of figure out what R is. It says find the diameter of the ball. So I bet R is going to be the radius. So once we find the radius, we just need to multiply times 2 to get the diameter. Okay, so let's see. I want to get R squared by itself. So I'm going to divide by 4 pi. Be careful if you're typing this in your calculator. You might need some parentheses there. If you did it correctly, you should get 625.001. And then we have this R squared. We need to get R by itself. So I'm going to take the square root of both sides. And I end up getting right around 25. And so let's figure out what this is. So it's 25 centimeters. And so I'm going to multiply times 2, and I get 50 centimeters for my diameter. Okay, so let's, we have got 2 more. So notice that both of these have the equation. So I'm trying to figure out, okay, well, what is H, what is T? Okay, so I found out that the height, or H is the height, and T is actually the elephant's age. We're not going to worry about using a graphing calculator right now. Okay, so it says estimate the age. So I'm finding T of height, who is 200 centimeters. Okay, so I'm just going to plug in 200 in for this and then solve for T. So let's see, let's subtract 75 from 200, 75.8, sorry. And I end up getting 124.2. And so I'm just getting that cubed root by itself. So I'm going to divide by 62.5. I end up with 1.9872. And so I'm thinking, okay, well, in order to undo this, I'm going to have to take it to the 3rd power. So I'm going to take both sides to the 3rd power. I'm going to end up getting about 7.85. So that means, let's go back up, T is the elephant's age. So the elephant is about almost 8 years old. It's about 7.85. Okay, so let's do this last one here. So we have an 8-foot ladder. X is the distance against the 4 from the wall. So we know that this is the distance. And then it says lean against the wall. The height of the ladder is, so this is the height. And what do we want to do? We want to estimate the distance that the ladder should be placed from the wall in order for the ladder to reach 7 feet off the floor. Okay, so just to be clear, this 8 foot, that's the length of the ladder. It doesn't say anything about that. We just want the height, which it tells us it's 7 feet off the floor. And we're trying to figure out how far out it needs to be. It's going to be set up like this, and I'm going to take, I'm going to square both sides. So I get 49 equals 64 minus x squared, and then just solve for x squared. I think what I'm going to do is subtract the 64. So 49 minus 64 is negative 15. So negative 15 equals negative x squared. I'm going to divide by negative 1. So it's going to look like that. Then I'm going to take the square root of both sides. So the square root of 15 is about 3.87. So that's how far the base, so if this is the wall and this is the ground, that is the length right here of how far it needs to be against from the wall. So 3.87 feet. And that is it.